Adapting an LLM to your niche can feel like PhD level work, but it doesn't have to be that complicated. You do not need to train from scratch. Just point your LLM at the data for fine tuning or use RAG to get instant domain smarts. Let's see how. Hello everyone. In this session, we'll explore how we can adapt a large language model to a specific task of your interest. LLMs are fantastic at handling general language tasks, but that doesn't automatically mean that they'll perform well in your unique scenario, especially if you need specialized insights. In this video, we'll walk through different strategies that you can use to customize the LLMs for your specific use case. By the end of this video, you'll understand whether you need to fine-tune your LLM or use a technique called RAG to solve the problem. LLMs excel in generating human-like text, like answering questions or summarizing information and things like that, because they are trained on huge amounts of general data. However, if your project requires in-depth knowledge about specialized things like legal documents or medical documents, engineering specs, or anything like that, there is a gap between what the LLM knows and what your users need. Adapting your LLM bridges this gap. So let's look at what are the strategies that can be used to adapt an LLM for your specific task. So the first one that comes to mind is fine-tuning the LLM. Fine-tuning involves giving the model additional information that is very specific to your field. It's a way of specializing the LLM so that it focuses on the nuances of your domain. However, the process involves more than just dumping a bunch of data into the training pipeline. So typically, you'll always start with a pre-trained LLM, an existing LLM that knows general rules of grammar and language, etc. This base model knows the general structure of language and some common facts. Now, what you do is you gather all the documents, raw text, everything that you have related to your specific domain separately. Then you clean this text to make sure there are no duplicates, irrelevant data, and things like that. And you make sure that it is representative of the knowledge that you would like your LLM to have. Now you can use this additional data that you have collected to fine-tune the model. And you can do this in two ways. You can fine-tune all the parameters of the model using this additional data, or you can use adaptive way where you use something like LoRA to only adapt a few layers or a few parameters of the model. So here you don't adjust all of them, but a small set of them in certain layers, which will save you a lot of computational power. So this data that you're using to train the model can be structured as instructions and then the output, like an instruction and output pair. You provide that data to these models, and this approach is common to conversational kind of models, or like instruction based text is what you provide. So you do multiple rounds of training, and then you evaluate the performance of the model, and then finally figure out which one has the best performance. And that is your fine-tuned model that you can use for your task. Let's talk about compute. So if you are trying to accomplish this using small to medium models like 1 to 7 billion parameters, then you can perhaps get away with, one or two high-end GPUs like NVIDIA A100, or you can just rent it from the cloud. But if you have very large models, like 13 billion plus parameters, if you have a larger model, then you may require many more GPUs or, groups of TPUs in order to be able to do this kind of fine tuning. And especially if you're tuning like all the parameters of the model, you need much more compute. But if you use LoRA or something like that, then the computational cost will be a little bit less. So let's assume you have accomplished all this and you have this nice fine tuned model with you. The next step is to serve the model. So, for example, when we go to a website and talk to ChatGPT, there's a model behind it which is being served by the company OpenAI. In this case, when you have your own model, you have to serve the model, which means you have to deploy the model so that when a question comes in, the model is able to process that question and provide an answer. You can use this approach of fine tuning if your domain is highly specialized, like something related to medical documents or legal documents, etc., which require the model to understand nuances of how to use it much beyond the general knowledge of how to form sentences in a language. And if you have the resources required to build something like this, where you fine tune, deploy, and all of these things, then yes, go for it. There is another strategy called Retrieval Augmented Generation, popularly called RAG. Compared to fine tuning, this is a easier strategy. In this strategy, you update your LLM's knowledge not by fine tuning it. So you don't touch the parameters of the model that exists. Instead, you do something different. You provide the additional information that this model might need in order to answer your question within the context of the model itself. There may be data that you prefer to not include in the model's weight. You don't want the model to have inherent knowledge about the data, but you still want it to answer questions. So, if you have a scenario like that, this is a much lighter way of making the model know certain information and answer your questions in a certain way. So, to understand this, think of all the knowledge that the LLM has, the pre trained knowledge, as something like a long term memory, where it vaguely remembers all of these things. While the context that you provide when you ask a question, that is something that is a part of its working memory, and it can answer questions within that context much better. So, RAG essentially leverages this idea of supplying the exact snippets of data that a certain question requires. So, the more relevant and detailed the context is, the better the LLM can tailor its responses. By supplying the exact snippets or the facts that the model needs, at the time of answering a question, it allows it to generate responses that are more contextually aware and domain specific without requiring any kind of retraining of the model itself. So let's be a little bit more precise. For example, if you ask an LLM, what are the latest product updates? How is the LLM supposed to know what product you're talking about and what updates they are? Maybe that was never a part of its training data, right? Consider providing it with a document that contains details of the latest product update. So you provide the document and then say, given this document, can you tell me what the latest product updates are? Now it understands what you're asking, and it has the ability to go through the document, understand its content, and give you an answer. Now the question is, how can you give the right context that is required for every single question that a user asks? How do you do that? This is where the concept of RAG comes into play. So let's start with a question. Let's say a user types, what are the latest product updates? Or something like, explain the benefits of our new medical device. Some question like that. So, from a user's perspective, they're just typing in this question. Behind the scenes, what happens is the system looks at the question and it searches its knowledge base to see where is the information that is relevant to the question being asked. So it looks at a knowledge base. We'll come back to what a knowledge base is. Let's assume there is a big pool of knowledge, not necessarily anything that the LLM has ever been trained on. Some new knowledge exists as a knowledge base. So when a user asks a question, it goes and looks into that knowledge base to see what are the parts of this knowledge base that are relevant to the question being asked. And it grabs all of those snippets, stitches them together as a context, and then recomposes the prompt to be, in this context, answer this question. It may need to summarize these snippets a little bit because it's possible that there are 100 snippets that are relevant to the question that you're asking, and they don't fit in the context window of this language model. In that case, it will simply summarize them in such a way that they fit into the context window and then compose the prompt to ask this question. So let's go back to knowledge base. What is inside the knowledge base? So you decide what should be inside the knowledge base. It can be all your customer manuals, it can be all the documentation, anything that you want your model to answer about. So all the information is saved in this knowledge base, and you can keep updating the knowledge base as new information keeps coming in. And the cool thing about it is you do not need to touch the large language model at all. The knowledge base is completely separate from it. So from a user point of view, the user just asked, what are the latest product updates? But behind the scenes, all of this exercise of figuring out the right context, providing the right context, and then asking the question is happening. So when is it a good idea to use RAG? So if your domain is fast changing, like there are, regular product releases, there's a lot of update and customer interaction information and stuff like that that keeps changing, then using a RAG is a good idea because you can keep updating it without touching the model. Also, if you have a broad knowledge base, like a large, corpus of documents, fine tuning on all of this data is very hard. So RAG allows you to tap into these documents on demand. And if you have restrictions that you cannot legally incorporate certain data into the model parameters, then RAG is a way to keep it separate. So the pros of using a RAG are it's a relatively lightweight setup, it is scalable, and in real time, if additional information is available, it is able to use it. The cons are that the quality of how well it responds depends on the quality of how well you're able to retrieve the relevant information. Since it only sees the context of what question you're asking in real time, sometimes it may lag any knowledge about the domain itself at a deeper level. A fine tuning model, on the other hand, is retrained on a certain data, so it has a little bit more of this internal knowledge built in. Also, there are always these context window constraints, right? Like if the snippets that you have fetched in case of RAG are really really large, they're not going to fit in the context window, and then you'll have to summarize and do different things in order to ask that question. So, to summarize, RAG is essentially a powerful alternative to fine tuning, where instead of embedding all of your specialized knowledge directly into the model weights of the LLM, you're storing it in an easily updatable knowledge base, and then you're retrieving the relevant pieces as needed. This approach can be more flexible, cost effective, and maintainable. Thank you for watching. And I hope that now you feel more confident about finding the right approach to make LLMs work for you. Stay curious and see you next time.